Today we're going to talk about laws of exponents. So we have these laws that we're more or less familiar with now because we have talked about them before, right? So remember, if you're multiplying two terms and they have the same base, when you're multiplying, you're just going to add those exponents, all right? Law number two would be if you have some variable that's raised to a power and then you're raising all of that to a power, well, you're just going to multiply the powers, right? On law number three that we used before, if you have something like this, a and b are being multiplied here. And if you have that being raised to a power, you're just going to raise each term to the power. The one that we're not so familiar with is this one. This one basically says that any number except for 0, any number raised to the 0 power would be 1. All right. Law number 5, you have that when you divide two terms and you have the same base, you can subtract. And finally, law number 6, which by this point we have done this before. If law number 6 says if you have a fraction, you're raising that to a power, you can raise the denominator and the numerator, and the denominator to the same power. All right, so now let's talk about what this would be. All right, so on this one right here, even though it's not written on here, -4 would be raised to the -1 power. So this would be the same thing. They have the same base, so I'm just going to add those two powers together. So this would be -4 raised to the 4th. Now remember that -4 raised to the 4th power would mean that when you're multiplying that -4 times itself 4 times. And when you do, you will get a positive 256. Okay, on number 2, if you have this number raised to the 2nd power and all of that is being raised to the 3rd power, we're going to use law number 2 and we're going to multiply those powers. So we have -3 to the 6th power. And I know this is difficult to know, like I would have to use a calculator myself, so all you need to know about this is because this is being raised to the 6th power, this is going to be a positive answer. Alright, so I understand that some of you, a lot of you, including me, would not be able to get that with a calculator. So just know that if you raise a negative number to a positive, to an even power, you're always going to get a positive answer. So on number 3, alright, this 2, you're going to basically multiply each power. You're going to multiply that 2 times each power, right? So that would give us, let's see, 3 to the 4th, x to the 4th, y to the 2nd. And I'm just going to leave it at that. That would be 81 though. But anyway. So on number 4, this right here, you're just going to multiply m7 times 1 over m4, and remember that when you divide you're actually subtracting, so you have m to the 7th minus 4, which will give you m to the 3rd. Alright, remember that again, when you divide you're actually going to subtract those powers, assuming that you have the same base. Alright, let's look over at number 5. On number 5, notice that on this one you have, this is one term and you have a plus here, right? When you have that plus, that kind of shows you that you actually have a term plus another term. So in this one, you're going to distribute this to both of these, right? So if I multiply xy squared times 3x squared, I would have 3. Now multiply that x squared times that x, you'll get x cubed, and then y squared, right? Similarly, if I do the same thing to this one, if I multiply xy squared to times 2y squared, I would have 2x, and that would multiply that y squared times that y squared, which will give me y to the 4th. Alright. Now on the next one, remember that any number, unless it's 0, any number to the 0 power would be 1. So all of this, doesn't matter how complicated it gets in there, all of that would be 1. Alright. On number 7, that may look a little difficult because you do have a variable here. Remember, use the same law. So if you're multiplying two numbers, you have the same base, then in that case you're going to add those two powers together, those two exponents. So the answer would be 4 to the power of y plus 8. Alright, because all I'm doing is adding those two. Alright, on number 8 now. On number 8, same idea. I'm going to go ahead and raise this to the 2nd power, which means I'm going to multiply here. So I have a to the 8th. B to the 6th, and then we have a to the 6th here, so this is what I'm doing now. So this is a to the 6th, b to the 3rd. And then the thing to understand is that there's many ways to do this, right? So this is not this is the way you have to do it every time. But for me, what I like to do is I like to combine everything in the numerator. So this would be a to the 14th power. This would be b to the 3rd over. So again, I multiply this times both of these, and then I'm going to divide all of that by b to the 6th. All right. Now, if I can simplify, remember, I know when I'm done when I have a single variable for each letter. So this I already have. There's no more a's here. There's only one a. Now I need to combine those two. All right. So when I combine those two, remember, now you can look at it two ways. You can subtract, and that would give you b to the negative 3. And you can bring it to the bottom. Or you can look at it like this. If I have b to the 3rd, that's the same thing as having 3 b's. B times itself 3 times, and I have 6 b's on the bottom. If I cancel those out, I would have b to the 3rd. All right, and again, for you that maybe you didn't understand, b cubed is b times b times b times b, and b to the 6 is b times itself 6 times. So that would give me b to the 3rd in the bottom. Okay, so anyways, that's that for that one. Let's look at number 9. In this case, we're solving. We're going to use those laws that we learned at the very top. So notice again that I'm multiplying those two. So when I multiply, I can add the exponents. And once I add the exponents, look at them. I have the same number here. So those two numbers are matching. So all I have to do is set those two powers equal to one another and solve. So again, once you have the same base, then you can actually just solve for the powers here. If I subtract 2 from each side, I get x is equal to 6. Alright, let's go ahead and go to the next part here. So now we're going to deal with negative exponents. And we have already done some of this in the past. But the most important thing about this is that a negative exponent does not indicate a negative number. Alright, so just because you have a negative 4 as the exponent here does not mean that this 5 is negative. Okay. So remember this also, if you have a negative exponent, you can make it a positive exponent by bringing that to the bottom of a fraction. Alright, so on this one, if I multiply, I'm going to use the same law. So if I multiply here, I'm going to add. So I'm going to add the powers. So this would be 5 to the negative 1, which is the same thing as 5 over 5 to the first power. Okay? Alright, let's see now. Good. Alright, so now I'm going to go ahead and do number 2. On this one right here, I have a power to a power, so this is 2 to the negative 6, which is the same thing as 2 over 6. And I believe 2 over 6 is 1 over 64. Let me see, let me think about that for a minute. Yes, alright, so 1 over 64. Now let's go and look at number 3 here. So number 3, I probably want to combine these numbers first before I do anything. So I'm going to combine those two. Remember, I'm going to add. So if I add negative 3 and negative 5, when I multiply those two, I'm going to get 8 to the negative 8, 8 to the negative 9. Now after this is really up to you how you do this. All right, if you have this, what you can do, remember what I said, right? If this is a negative exponent, I can bring this whole thing to the bottom. So this would be 8 to the 8th, and this would be 8 to the 9th. And then now you can subtract those two if you like. Right? So 9 minus 8 is 1, so I have 8 to the first power. Okay? So number 4, again, this is not the only way to do it, but if you distribute, because I have this raised to a power, I can raise the numerator to this power, and I can raise the denominator to this power. And then I can bring this to the bottom, make the exponent positive, and I can bring this to the top and make that exponent positive. The goal here is to do this without a calculator, especially when dealing with numbers, so I'm going to leave it like this. Alright, number 5, we're dealing with some variables now. But it's about the same, all right? So if we're multiplying actually two fractions here, so keep that in mind. So what you can do to make this easier is you can actually try to reduce this fractions. You can also reduce across here if you like. But right here, this seems to be easier. So this would be a 1, this would be a 2. This can now be reduced, so I'm moving on. So what I have here is I'm going to have 5 over 16, alright? That 16 came from multiplying 8 times 2 here, and that 5 is this 5. Alright, so now Again, what I'm going to do first, I'm going to multiply everything in the numerator together. So I'm going to multiply x to the negative 4 times x to the negative 7. And remember, you're going to add those powers. So I have x to the negative 4 plus times x to the negative 3, which will give you x to the negative 7. And then now I'm going to multiply these two, which will give me y to the 8th, because I'm going to add those two together. Alright, on the bottom, I have x to the 5th. Well, on the bottom there's really nothing to do, just other than just rewriting the equation. Alright, now, again, how you do this is really up to you. You might be able to do it faster, and that's okay, as long as we get the same answer. So, now on this one, what I like to do after that, especially if you find this kind of difficult, is I like to bring everything that has a negative exponent, I like to put it up in its appropriate place. So this is a negative exponent, so I'm going to bring that up. This has a negative exponent, so I'm going to bring that down. And then now I can combine those. I'm going to multiply those two, which means I will add here. So we have y to the 12. This is x to the 12. Alright, so that's it for that. Now moving on to, let's see, let me do number 6 here. And I'm probably, well, we'll see if we do number 7 here in a minute. But anyway, so I'm going to go a little bit faster on this one, right? So we're going to reduce this here. We got a 1 over 3. Right here we have a negative 1 over 3 here. Okay? Now again, what I'm going to do is I'm going to combine this stuff together. So I have, let's see, negative 1, this is x to the negative 4, this is y to the positive 1. On the bottom I have 3 times 3, which will give me 9. Yep, okay. Then I have those two, so I'm just going to rewrite those two like they are. Alright. I'm going to get rid of those negative exponents. So I have a negative 1, x to the 3rd, y times y to the 5th. Alright, notice that I brought those two up, and I'm going to bring this one down over 9x to the 4th. So this would be, all of these will give me one here. So I have negative y to the 6th over 9. Let's see, 9x. Okay. And again, if you don't see what I did here, essentially I subtracted, alright? So when I subtract those two, I get x to the negative 1, which I'll bring to the bottom. Or the way that I like to see it is that I have 3 x's here, 4 x's here. If I cancel them out, I end up with 1 x in the bottom, alright? Now let's see, on number 7. On number 7, I'm going to try to combine everything on top here and everything on bottom, if I can, but there's nothing to combine. So I'm going to go ahead and I'm going to bring whatever's positive up here, whatever has a negative exponent up, which that's the only one, and then this one is negative, so I'll bring it to the bottom. Let's see, I'm going to bring this to the bottom also. So just to recap, I brought these two down and I brought that one up. Alright, so again, notice that those two are now here, and then this one's up here, right there. Okay. So now, on this one right here, I'm going to have to raise everything to the second power. So this is negative 4, this is y to the positive 2, z to the negative 2, and z to the negative 6. And by the way, if at this point, if you get the idea, you should probably just go ahead and show your homework. Alright, this can be pretty annoying to do, kind of tedious, but it's a tool to help us on the next section. So, let's see. I'm going to simplify this just because I'm ahead on this one. Alright, that's going to give me 1x, that's going to give me 1y. So on this one, all I have left is y over z. On this one, I have z to the 6, y squared, and I have x to the 4th, z to the 2nd. Alright, let's go ahead and get rid of some of these. So this is going to be to the 4th power now. So now this is going to give me y cubed. Let's see, z to the 4th. over z x to the fourth. And finally, I'm going to cancel one of these. So I have y cubed, z cubed, x to the fourth. Alright, and like I said, there's very many different ways. So if this last one confused you, is because I used whatever way I thought was best. Many ways to do this.